Welcome to your second video for Chapter 1, Section 1. It's called Classifying an Equation. We're going to do 3 examples again, and let's go ahead and get started. I have a little bit of vocabulary that we're going to introduce. So let's take a look at this first equation that is asking us to, pardon me, didn't have the directions up there. Determine whether the equation is an identity, an inconsistent equation, or a conditional equation. And we're going to start actually with the last one, a conditional equation. So let's take a look at this one. And we're going to look at one of the previous examples that I gave, and that's this right here. When I look at this equation, excuse me, okay, when I look at this equation, it appears to be that all I would have to do is use the addition property of equality to get the x alone. So that's what I'm going to go ahead and attempt. So I'm looking at this. I get 4x is equal to 12. And indeed, I don't have any weird situations that arise. And so there's only one answer, and that is 3. And so this is a conditional equation, meaning it is true if x equals 3. If we use the value of 3 for x, then it is indeed going to be a true statement. So let's take a look at a second one. Okay, the next one we're going to look at is an identity. So I'm going to give this a different color coding. Identity, we'll make that one green. Let's take a look at this example. Here's the original equation. Now, implied in the question, determine whether blah, 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 is that we can't necessarily know ahead of time. All right, so we have to do a little bit of stuff to these equations. So I need to just do some work. So what I'm going to do is I'm going to look at this problem, and I can't tell necessarily whether it is an identity, a conditional, whatever. And this one is going to end up being a little different than the last one. Let's take a look. So we have 4x plus 4 when I use the distributive on the left. We have 10x plus 4 when I use the distributive on the right. Now, on the left we still had a 6x, so I'm going to take a look at combining my like terms here, right? Before I move across the equals, I'm going to combine my like terms. So that's going to be 10x. And some of you are going, oh my goodness, look at that. You're already seeing it. So look what I have. I have 10x plus 4 is equal to 10x plus 4. Now, folks, if I asked you which one of those things would be considered an identity, or excuse me, the first or the second, or inconsistent, you might wonder, well, maybe that's inconsistent. But folks, this is an identity. Now, how do I know it's an identity? Let's just keep going. Let's say that you didn't notice that these things are exactly the same, which makes it an identity. Let's go ahead and continue to get, let's go ahead and continue to get the, the variables all located in one spot, which means this, right? If I didn't notice anything about it, I just keep on plugging away, trying to get my variables in one spot. I notice that those go away, and I get a 4 on the left. Wow, and I notice those go away, and I get a 4 on the right. Now, here's what I do. I say, wait a minute, when the variable disappears, guess what I'm going to do? I'm going to put a big old stop sign right there. Stop! When I notice the variable goes away, then I need to stop. And I need to ask myself a question. Is it true or false? That's the next thing I need to do. Well, I'm looking at this equation right here. There are no variables, so I can't finish it in the standard way that I finish an equation. So I just need to finish by answering, is it a true or false statement? Well, that 4 equals 4 is a true statement. If I end up with variables disappearing, and then it ends up being a true statement, then this is called an identity. What do you mean by the word identity? It just means that any value of x will make it a true statement. Any value of x. Think about it. Back when I saw this right here, if I'd noticed it at this point, let's put in a value of x as 1, right? So that would be 10. And that's going to be 14 is equal to 14. In other words, it doesn't matter. It's going to be true for any value of x, any value. So we call it an identity. Can I list all the values? Can I put them in a solution set? No. No, it's basically, if I wanted to list them in a solution set, I would have to say all real numbers, right? I'd have to say all real numbers. because it's an identity. All right, so I could say all real numbers, right? Because everything works for x. All right, let's take a look at the last example. So far we've had a conditional equation, an identity, and this last one is going to be an example of an inconsistent. So here we go. We have 5x is equal to 5x minus 8. You're going, yeah, that's not going to work. So let's just say I'm just plugging along here. I'm just going to get my x's in one location. Again, do you notice the pattern? Every time I'm trying to solve an equation, I want to get my x's all in one spot first. However, as I do that, I notice that that goes away, and then lo and behold, the 5x minus 5x is also added. They're additive inverses, which means they go away. Now, look what happened. No variables. The variables disappeared. What do? We draw a little stop sign. We say stop. Stop. The variables disappeared, right? So I'm going to say variables disappeared. The variables disappeared, right? So we stop. And then what do? We ask ourselves a question. Is this a true or false statement? That's the next question. True or false? I didn't mean to put that there. I'm going to be picky and put it right there underneath the other one so it looks like. Okay, so true or false? Well, this is obviously a false statement. 0 is not ever going to be equal to negative 8. So if I chose false, then that means that I can't list a nice, neat little solution set because nothing works. And so we call this one inconsistent. There is no solution. It's inconsistent. So we could say null set. If you really wanted to put something, we could also write no solution. All of those answers would be fine. A no solution or null set, but the kind of equation is inconsistent. Okie doke. Thanks for listening.